Hello, hello guys. Hey, we are live streaming. Let's see if this works so we can start. Wait a second. Okay, yeah, we got it. We got it. Okay, so welcome back, guys. We are live streaming, and yeah, you enjoying the World Cup? Yeah. Okay, guys, so as usual, we are going to start a live streaming building an LLM from scratch using ROS without any experience. So I wanted to help you out to understand my journey and just play around with ROS and try to debug ourselves using Stack Overflow and the actual documentation without using AI for most part, because we do want to go back to the fundamentals and back to learning things without really knowing everything. So yeah, this is just my learning experience and my journey, and I hope we can get a LLM working with this system. But yeah, it is pretty cool. And yeah, let me show you what we have so far. We were able to create this split keep. Is a function that we are using just to get rid of this the the empty space that we have in our text. Essentially, we are at the first stage, which is data preparation for the tokenizer in an LLM, which is an essential part of how the LLM will learn. So we are going to the real fundamentals on LLMs, and we are following Sebastian Rashkap book and GitHub repository to learn how he did it and how he managed to do a lot of or the end-to-end pipeline of building an LLM from scratch. So yeah, this is pretty cool. I mean, we were able to import the buried.txt, which is a bunch of text that we have here. We count the characters, then we use regular expression. Everybody hates regular expression. We love it in this live streaming because it helps you to get out a lot of cool stuff or a lot of stuff from or removing stuff that we don't necessarily want from the LLM, right? Or for the data that we are going to pass to the tokenizer. Then we remove the empty space or the white the yeah the empty space, and we use like currently at this stage we have a vector string, which we learn that is kind of like it is a list of strings essentially would be the equivalent in Python. Then we prepare a hash set, which was pretty cool to get only the unique values. The okay, yeah, we have the hash set, the unique, which are the unique values. Then we iterate, we sort out the vector. Then we print the vocabulary size, and then we iterate, and we have everything together. So let me show you how it works. Can we run? Okay, it didn't. Why it didn't work? Yeah, I think it's for this, right? Yeah, it won't work because I have this here. Okay, yeah, but I think if I do this, and I think I can comment out as this. Didn't work. How can I comment a block of code? Does anyone know? Let's check. As always, we are going to respect the rules. How to comment a block of code in ROS. Okay, just one. Okay, so this is how we comment a block of code. We just have this inside, and I think we can run it because I think that was the issue. Is this part of the stuff? Yeah, yeah, I think so. Okay, so we maybe will put it this. Okay, we got it. Let's run it again. Yeah, it compiles. Okay. Yeah, essentially what we have here is that we were able to map out the words with an ID, and that ID is a unique identifier for that specific word that we have. And this would be pretty cool because now we are translating everything from words into an integer or an ID, or a number, which will help a lot with what we want to do right now. So yeah, this is what we have so far. The next step that we are building is to build the tokenizer. And this is a pretty tricky thing to do because we are entering into a new field, which is kind of inheritance and polymorphisms and a lot of fancy words that are just for describing a object-oriented programming. But I think that doesn't exist in ROS, so object-oriented programming is not a thing in ROS. You can do some type of abstraction, but I don't think you can do per se object-oriented programming. But yeah, we are going to try to to do this. So, okay, essentially what we want here is we have the tokenizer. I don't think this is the correct way of doing it. Yeah, maybe we can start by, let me think. What do we want? I want an example on a token, or not a tokenizer, but I want an example on how to create classes and methods in rows so I can kind of copy what we are doing here. And I want to start by initializing the vocabulary, which I think will be here at this stage. And from that stage, I want to pass into the different functions. So perhaps we can start out with something simple, like the most basic thing to do in raw, or the most basic ROS implementation on this class. So let's start by searching classes in ROS language, something like that. Okay, I like this question. Why ROS doesn't have classes? Because it answered one of our core questions, but at the same time, is he have another documentation that says object-oriented programming, a gentle introduction to ROS. So yeah, wonder about confusing things. Let's check why. Let's check this. Why ROS doesn't have classes? Everyone's question. So the main thing that's missing from ROS is implementation. Okay, the main thing that's missing from ROS is implementation inheritance. That is, you can have a concrete struct X that inherits from and can be upcast to another concrete struct type Y. And frankly, good for ROS. Okay, so this guy what he's saying is you have all the features, but you don't have inheritance. So you cannot do it. You cannot create a struct and then import that struct to another struct or something like that. And I think it makes sense, but I don't want to read everything here. I want to see an example. And I think the best place to find example is at this stage. Okay, let's read it. I think this is valuable, so please pay attention to this. Let's start by object-oriented in ROS. Everyone comes from software. and the chances are good that you provide your previous programming language implemented object-oriented programming in a particular way. Yeah, we came from Python. Classes act as factories for generating objects, often called instance. Yeah, and define unique types. Okay, yeah, I think that's kind of what we're trying to implement. Classes may inherit from other classes. The parents inherit both data fields and behavior methods. But I don't think we really do need that, because Sebastian, what we did here is just implemented a class. So we don't really need the inheritance at this stage. We just need to build something from scratch. So I think this is perfect implementation for us. So okay, if B inherits from A, then an instance of B can be passed of something expecting A, subtyping. An object should hide its data encapsulation, which can only be operated on with methods. Yeah, I mean, let me jump into the example. Consider the example first used to introduce treats. Okay, treats show. This is a function self string implementation show for I. Okay, yeah, but I'm using this show here. Let me see. Okay, yeah, I'm using it here. I like this example. Let me check. I love this example because it's what everyone learns, but I don't really know the way it is implemented. Let me see if I can have something different here. Object programming is a way of modeling programs. Object as a programmatic concept were introduced in the programming language similar in the 1960s. Yeah, that sounds fair. Those objects influence Alan Kay's programming architecture in which objects pass messages to each other. To describe this architecture, he coined the term object-oriented programming in the 1977. Many competing definitions describe what object-oriented programming is, and by some of these definitions, Rust is object-oriented, but by others, it's not. Okay, yeah, I mean, I don't think we do need all these kind of fluffy details. So we can just keep with the fact that Rust implements some ways of object-oriented programming, but I think it's a matter of debate. I don't know. We are entering in a difficult field, to be honest. But I don't want that. I just want to see an example. Give me an example. Okay, let me check this out. Pop stroke average collection. Okay, stroke that maintains a list of integers and average. One thing that I love, or one thing that I usually do when I'm trying to implement anything or something, is I want to go side by side because it helps me to understand what's going on. And I love this Rust playground because it allows me to type a lot of cool stuff. I wanted to split. I want to split this screen so I can have it right here. Okay, so we have it here. Let me remove this out. Okay, let me start from scratch. Okay, so what it's saying is that we start with pub. I think this pub is for publication because everything in Rust by default is private. So yeah, we do need to start with this to kind of make it work, because even if not, it will throw an error like usually Rust does it. So we start with average collection. We open brackets like normal people, not Python people. Okay, we define that this is going to be a vector of I32. So I think this is kind of like a float, or yeah, or vector of numbers. An average. I don't know what this F64 mean. Does anyone knows what is this? Let me see. Encapsulation, the highest implementation. Another aspect commonly associated with object-oriented programming is the idea of encapsulation, which means that the implementation details of an object aren't accessible to the code using that object. Therefore, the only way to interact with an object is through its public API. Yeah, which what we are doing here. Code using the object shouldn't be able to reach into the object's internal and change data or behavior directly. This enables the programmer to change and refactor an object's internal without needing to change the code that uses the object. Yeah, so kind of like it works in Python, but I think in Python you can do whatever you want. You don't have to specify anything. So we discussed how to control encapsulation in chapter 7. We can use the pull keyword to decide which modules, types, functions, and methods in our code should be public. And by default, everything else is private. For example, yeah, so in Python, you don't force anyone. You treat everyone like an adult, and you have some conventions into capital letters. Or I think in Python you start with something like I don't know, like this should be private or something like that. I don't really remember, but that's how you tell other people don't mess with my code. Yeah. But in Rust, you define it explicitly, so you cannot change it. Yeah. So for example, we can define a struct average collection, which we already did here, that has a field containing a vector of iterative values. The struct can also have a field that contains the average of the values in the vector, meaning the average doesn't have to be computed on demand whenever anyone needs it. In other words, average collection will catch the calculate average for us. Okay, so what it's saying here is that you don't need to calculate over and over. The this by default will give you the average value, and it will catch this out, so it kind of will store. The struct is marked proof, which is public, so that other code can use it, but the fields within the struct, which is this, remain private. This is important, and this is in this case because we want to ensure that whenever a value is added or removed from the list, the average is also updated. Okay, that makes sense. We do this by implementing add, remove, and average methods on the structs as shown in listing 18.2. Okay, that makes a lot of sense. A lot of sense. Yeah, so I define the struct and this would be calculated, but this is kind of that what we store here, and it's the same thing. We do want to store the vocabulary, but we also want to store so the vocabulary stores words to IDs, and the integer string is integer and string. So you have both sides. So if we wanted to implement something like this, we start with this field, I think, right? So what's the vocabulary? Okay, the vocabulary is a 3, B3. Okay, so the vocabulary is B3. So it will be vocab B3 map. So like this, perhaps vocab B3 map. Yeah. Or yeah, I mean it should be string to hmm I don't know. I don't know what should put here, but it's what I'm passing, right? But let's keep going with this example. So then we implement the average collection. average collection. Okay, which is kind of what we define here. And I'm guessing that this needs, oh, okay, so if, okay, so this would be like the definition, but you don't need to pass the actual values. Yeah, I think that was pretty obvious, but I didn't catch at the beginning until I typed this out. So it would be public function add. So it would be mutable self that value I32. Okay, makes sense. Open brackets like normal people. Then self list push value. Okay, self up, update average. Okay, that makes sense. Public function add self list push self update average. That makes perfect sense. Okay, okay. Let me do this. Public function remove, and it's kind of the same. You just need to put mute. Okay, you don't type comma like Python. Yeah, I hope you see that I'm really biased to do things in Python. But I think it's pretty common. I think whenever you are learning a new programming language, the most common thing to do is to use the knowledge that you have, so you don't kind of build everything from the from the air. You want to have some mental framework on how you do things in other yeah, in other related fields, so you can kind of extrapolate to what you're learning, because if not, it will be insanely difficult to put things together. Okay, let result equal to self that list that pop. This is surprisingly familiar because, yeah, on this you have push, you have pop, but I don't know if it was defined at any point in time. But yeah, let's keep going. Resolve some value. I mean, I don't know if we really need all these things. Self update average some value. None. I don't really know what this means. But what I'm seeing here is I'm kind of defining this. I'm kind of using everything that we learn here. Yeah, but I think we should go to the end. Yeah, so it is a comma. Yeah. I don't know, man. I really don't really know what's happening at this stage, or what this means, for example, or even what some means. It seems like this is removing so like this is a method to remove things from Rust, and or for from this struct, which is an average collection. So what I know that is happening here is that you store a list and you store the average on the struct itself, so you doesn't have to calculate every single time, but you have a functions or auxiliary functions to help you out, which will be the add and the remove. So every time you add a value, you update the average, but if you remove the value, you don't update the average. That's kind of what I understand that is happening here. So yeah, let me keep going just to see if we understand a bit more. Average. And it's funny because it also use self. F F F64. Okay. Okay, that makes sense. Update Okay, okay. Average. That's it should be why this is private. Oh yeah. This is private because we don't want to people mess around with this. Let total. Okay, so how can I use yeah. Yeah, now that it's complete, I don't know how to use it. Will this run? I don't know guys. Hmm, this is getting hard and hard. Really difficult, right? Okay, so this is another thing. What is this? Okay. Further part of the process of learning rows is learning how to read the error message the compiler display. This will guide you to our working code. As such, we will provide many examples that don't compile, along with the error message the compiler will show you in each situation. Note that if you enter and run a random sample, it might not compile. Make sure you read this surrounding text, see whether the example you are trying to run is meant to error. In most situations, we will lead you to the correct version of any code that doesn't compile. Ferris will also help you distinguish code that isn't meant to work. Okay. Yeah, but you lost me where I was. Okay, you lost me. But I was on object-oriented programming. Let me see. Okay, this is implementation. So this doesn't supposed to run. I think this does. Let me let's run it into the oh yeah, was here. Yeah, didn't work. Hmm. But I think we can use AI to ask for a simple example because I don't know why it's so difficult to find. Give me a simple example of ROS object oriented programming. I come from Java world, so please excuse me as complete ROS noob. In my object oriented stuff, there are common methods as well as object type. I want to do this in rows but fail. If you choose to use enum, then you need to match the enum accomplished things with it. The proper implementation of speak would be har- implement speak for animal. However, if the trait has more than one method, it might make more sense to match only once to produce the trait. This is more verbose by itself, but lets you avoid writing one match per method of the speak thread. There is only one method. Then use the first version. Thank you very much. I guess there is not much all construct will even you from having to trade. Unlike inheritance in object-oriented, an enum is a closed set of types and you use pattern matching. Okay. Yeah, but this doesn't help. Okay, let me see. What's the difference between abstraction? Define a common behavior using a thread. Encapsulation define the data structure similar to class. I think that's what I want, right? Okay, I want to implement this. Let me implement this side by side with my ROS compiler, and then we kind of go from there. ROS playground. Okay, and we want to divide the screen. I don't need this. Yeah, I do need this. Okay. Okay, let me start from scratch. Okay, so I don't want this, but I do want to encapsulate. Okay, so we start with pub, which is public, the struct which define the type. We have dog, name, which would be a string. Yeah, we have public, breed. So kind of we can change this thing. So private field by default and public field. Yeah. So we have our struct. Okay, that makes sense. Okay, let me just go with the doc. So we implement doc public function new name. Okay, then self. Then we use doc. Then we use name. And we use name to string. Yeah, because we are using what, yeah, so this we are defining a function and we are passing the dog, which is the struct, and this requires a name, which will be a string, but also requires the breed, which will be also a string. I don't know why we need to do these two string. It's, oh yeah, because this is str. Yeah, that makes sense. Yeah, but why you just put it string here? But anyways, okay, I don't want to mess out with this. Okay, so we have this implementation, the public function of the dog. Now we create a dog with the name and the breed. And we do want to access to the name. So it will be pub function get name, pretty similar to Python, right? And then we use self. So we are not passing any variable, we just passing self, which came from yeah, from the struct. Then we use str, and from this str we create this self that name. Yeah, so this is how we access to the name. Okay, so we implement the doc. Let's put the main function. Let my doc equal to doc new. The name is body, and it's a golden retriever. Yeah. So I think I can do this print LLM. Will this work? Body. Okay, okay, this work. So I think we have a good understanding on what's going on here, and it's pretty similar to Python. Let me see if I can implement something of this. So I have the simple tokenizer, and the tokenizer I want to pass the vocabulary, but I also want to pass the, so that I don't want to call vocabulary, I want to call int to string to int. So it will be like this, str to int, which would be a B3 map, or maybe let me just put it here so we can kind of have the reference, and so we can go over this. Okay, so we define the struct. This will be public struct, simple tokenizer. Then we start with string, and then into str, which will be, I don't know if it will be a B3 map, but let's put it this for now. So we have the struct or class. So that's how we start. Then we have the implementation, but the implementation will be, okay, yeah, this is correct. Implementation, we pass the struct. Then we have the function, we have defined function. This would be a public function, I guess, public function, encode self raw text. Hmm. Do I want raw text? Raw. Okay, let me see. Yes, I do want raw text because this raw text is what we are going to create the regular expression. Okay, yeah, raw text. Raw text, we create the text, we pass the regular expression, we process this. Okay, so I want to go from raw text to the ID. Yeah, just printing the ID. So this would be the encode raw text to string. Okay, I'm passing to string, regular expression. Then we process, we remove the empty spaces. Then we create the ID speed tree map. Then we iterate and then we insert only the ID. So I think I don't have to return, right? No, I don't have to return. Or maybe I do. Yeah, no, I don't think so. Okay. So this is in code. So perhaps, so if I run this, okay, so this, I'm supposed to already have this completed to get the IDs. So I didn't use in any way the vocabulary, right? Yeah, no, I don't think so. So why the hell is there? I mean, I don't know, guys. So yeah, I mean, because I'm defining here the vocabulary string to, oh yeah, it's here. Yeah. Yeah, it's in there. But I don't really know how to translate this. Yeah, because I have it. I so what I have here. This is the regular expression we have here. They use they use this strip kind of stuff. So this is already covered. So this is already covered, but I don't. This is already covered. We have the pre-process. Then need to go to the IDs. The IDs I cannot iterate over. Yeah, this will throw an error because I don't have it. But I do have the self the self dot str to init. That how we do it? No, to be okay. So I have self dot name, self dot and iterate. Yeah, but in this implementation, I should start by defining it. It will be implementation pub fn new. Yeah, because I want to create a new one, and this will be str to init. Yeah. Yeah, maybe I can just put vocab. Let me remove this for now. Str to init. Okay, vocab. And the structure would be a B3 map. I don't know if I can put it B3 map. Okay, B3 map. Vocabulary B3 map. This is what I have here. table the function, then doc, close doc, but everything, this is close. Simple tokenizer, okay. Maybe I can put str to in, and it will be vocab. I mean, I think that's what is happening here, right? Because string to integer is just the vocabulary, so that's it. So that's what is happening here. And as I only have one, and the vocabulary, okay, I close this out, and I close this out, and then I close. No, okay. Let's see. So we have the public function, then we, yeah, so we kind of inheritance. I don't know if it is the correct terminology, inheritance, but yeah, we are using it into the function, the struct, right? So we define a new one with the parameters that we have. In this case will be vocabulary. Then we map this out to self, and from that self we create the simple tokenizer, and then we pass what we need. And yeah, we close this bracket, and then we define a new function, which in this case will be the encoder. So yeah, self, yes, yes. Yeah, so I think we have the encode part already solved. I hope so. Is this empty? Oh no, no, this is not empty. This close this one, and this close this one. I really like that these have colors, it because it helps a lot. I didn't really realize until now. So how can we use it now that we have the struct and the implementation, a list of the encoder port? I just need to pass a vocabulary, right? So okay, so we have what, but if I pass a vocabulary, what do I need this for? Hmm. Let me see what is happening here. Vocabulary. So the IDs are used to the encode part. Hmm. Let me grab some coffee, guys, and we can think about it. I'm kind of stuck because I think the core fundamental part is I'm trying to do what I know from Python. I'm trying to do it into Rust, and there might be some nuances that I don't really understand or know. And yeah, but that's a cool question. I mean, do I return with this struct? I think it's pretty direct question. So maybe can I return? Can or should I return things from the functions that are defined from this struct? I hope this makes sense. So he said, yes, you absolutely can and should return values from the struct methods. Why not? Right? Returning values is fundamental for data retrieval, state checking, and method chaining. Here's a guide on how and when to return things from struct methods in Rust. Returning data getters. Yeah, that's kind of what I want. Because struct fields are private by default, return values to safely expose data to the outside world. That's what I want. I want to the IDs. So returning a reference if the data is heavy, like a string or vec to avoid exposing copying. Return a copy if the type is small and primitive, like I32 or bold. Okay, that makes sense. So I defining the username, and login account. So implement a user, which you already know. I already know. So the public function get username and self username. Returns a copy. Returning self constructs builders. Okay, implement user, a new user. Returns a result to handle potential business logic failure. Oh, but I can use return. So maybe we can use just return and that's it, right? From the code. So I think I can return these IDs and then I can print those IDs. So I need to pass the vocabulary and the raw text. Yeah, but I mean, I think it's any. I'm skipping a step, yes, but I think I can do something like this. Simple tokenizer, new. So this will be vocab and yeah, vocab. You see one of those examples help. Hmm. I don't really even know how they pass Wait. So tokenizer, okay. So I have this tokenizer. Let tokenizer. Let text. Will this work? If this work, I'm a fucking genius. And if I am genius, you should get me into any of the major companies. Yeah. If this work, I'm a genius. Yeah, I'm pretty sure it won't run. Yeah, yeah. I was. Oh, yeah. Maybe we just need to comment out. Okay, it didn't work. Let me check. Okay, we have an error here, and the first one it says that it didn't recognize this pre-process, but I don't know why. It's the same. It's the same that the one that I'm using. But where is the R split? And I'm not using any R split. Because that's Python. I'm not using any R split anywhere. Where did you get that from? Yeah. Okay, so there is another error here. Okay, it says that I'm missing something, which I think is when I define, I need to say what is going to be output. Python you can do, but this is optional in Python. So I don't know what to put here. Yeah, B3 map. Let me clear this out again. says expected one off, or here in this encode. Yeah, because I cannot just say I need to put raw text what this will be, and in this case it will be str, right? So let's start again. Let me clear. Yeah, but I think it's really helpful, the functions that we have here, right? Oh, okay. Yeah, but I think it's far away. I mean, yeah, perhaps this will work. This work, I'm a freaking genius. And you should tell all your friends that that the genius is live streaming. Okay, it didn't work. Let me see. ID's insert argument 2 is missing. Why I need two arguments? Let's find out. Insert in rows. Okay, so I need to insert 3 at index 2. 0, 1, 2. Insert apples at index 3. How to insert in rows at the end of the vector. Yeah, push. Okay, maybe we can just use push. Will this work? Hope so. Okay, it didn't work. B3 map. B3 map is complaining about that I need to say something more about what do I want to store, but I don't know what do you what this is expecting from me. It's missing generic argument. So B3 map is a hash map. Maybe I can put it this. I usually did this when I was learning anything. So notify about strings. Hello, I was working through the Ross book and implementing org type to represent a company. This maps department in order. Okay. Hmm. Maybe a Stack Overflow will help. I'm trying to use a share semaphore using 4 years ago features. Yeah, it's really not the same error. Hmm, maybe, but so why a B-tree map? I don't know why a B-tree map if it is a vector, really, right? And it's not any vector; it's a vector of integers. Vector of I32, I guess. Okay, I fixed this. Let's see if this works. Okay, so here it says a simple tokenizer doesn't have this field. The fields are vocab, and I'm trying to pass str to int, which is kind of the same, right? But I don't know. Let's just put str to int. Yeah, it is exactly the same. I don't know why Sebastian did that. I don't know why Sebastian changed. Maybe for descriptions. Okay, so here is saying that I cannot print without using perhaps this value. Yeah. Yeah, because it's a vector, right? Okay, another problem cannot be format. Okay, this is the old one. Okay, use. It says that I should use this structure instead of to specify lifetime type or const argument. Let me IDs. Yeah, but where? Where is this? 67. Okay, let move IDs vector. Okay. B3 map expect two arguments? I think it's a vector of strings. No, but it's not a vector of strings. Yeah, but I never define it. I just start a new B3 map and then iterate and insert everything there. So it wasn't like, so it's saying that I'm missing this. Expected at least two arguments. So perhaps will be a vector of strings. I don't know. Yeah, I don't really know. But it should, right? Let me go with B3 map Ross arguments. Okay, B3 map that new. Okay, B3 map that new. Okay, so what if I already have the B3 map? This says 92. Okay. So what this B3 map has? So it has a vocabulary, so it will be a string and I32. Okay, that makes sense. And str and I32. Let me see if that works. Clear. Okay, another B3 map error. It will be on this bar, which should be 52. Yeah, B3 map. So let me copy this out and put it here. Yeah, a couple of errors, but we are managing this how to solve it. Okay, expected name lifetime parameter. Consider using a name lifetime parameter. So he's suggesting that I put this. Okay, I will listen to you. Okay, let me see if that works. Okay, expected a lifetime parameter. Yeah, okay. Wait a second for me, guys. Need to do something really quick. I'm back, guys. Okay, okay. Let's keep going. Let's keep going so we can wrap this up. So I have another error here. It says I should add this into the implementation. I don't want to fight with the ROS interpreter, so I'm just going to comply to his commands. I will be surrendered to the ROS god of the command line errors. See if we can debug ourselves. Okay, another. Okay, let me add this. I don't know why do I need all this, to be honest. Maybe, yeah, maybe I need to learn a bit of the fundamentals. I don't really know why I need this. Okay, so I have another error, which is this one. Let me clear. Okay, has no field string to integer. So what should I do? Maybe self. Yeah, wasn't I? But I'm surprised how descriptive is the errors in here. I don't think we can get that kind of explanations in Python. When we make an error, that's gone. Maybe it does should be like this, and the vocab, which I don't need, but I do need this self. Okay, that makes perfect sense. I don't, String to integer. Yeah. Okay, guys. About to give up. Yeah, it is getting difficult to, but I don't really understand what we are doing wrong. Maybe, yeah. Let's use the AI for this. I'm having errors with this implementation. Give me, explain me what am I doing wrong without applying to my code. I I want to learn, so help me to understand my errors. Okay, better, I promise we won't use AI, but sometimes we need it. It's just a matter of using the AI in the times you need it to debug ourselves. Once you try a lot of different things, and I'm sure I just want the AI help me out to understand, because I don't I'm really stuck in this process. So yeah, let's see. Okay, so here's a detailed breakdown of the original implementation and the concepts behind it: struct instantiation systems and the self keyword. Okay, okay, I think we started here. Okay, I need to put where in 55 here. Vocab. Okay, the error expected identify found keyword self. Why it happened? In ROS, self is only valid inside method signatures like f and encode self. Yeah. To reference the current instance, when initialize a new struct, self does not exist yet. Struct literally syntax only requires the field names directly. How to fit remove the self and initialize it as string vocabulary. Okay, so I need to remove the self. Okay, yeah, that makes sense. Constructor signature versus instance method signature. Okay, I have both new self vocab self. The error. This function takes two arguments, but one argument was supplied. Oh, really? On 137. Because this signature of new includes self as the argument, Ross treats it as an instance method. An instance method must be called on an already existing object. Tokenizer that new vocab. Example, tokenizer that new vocab. Since you are using it as an associated function, similar to a static factory method in other language to construct new object through simple tokenizer, it must not take self. How to fit? Remove self from the argument of new. Okay, may here, yeah, yes. Lifetime num ensure implementation block lifetime matches struct. Vocab b3 map self. Or do I need to put this out? No, I don't think I need. I don't know. Maybe I'm doing something really wrong, but I don't know. Missing fields and encoding logic. In 68, here no fit vocab on type simple tokenizer. Okay, what happened? The simple tokenizer through definition does not have a field named vocab. The only defined field is a string to integrate logic error. The encoding logic should look up each token from the preprocessed text in the vocabulary rather than iterate over the vocabulary keys. How to fix? Change the iteration to loop the tokens in preprocess. Loop them up in self to string and collect the resulting integer ID. For example, let move IDs back. Yeah, but I was doing that and your compiler complains about me doing something wrong. So for word, okay, that makes sense. For word in pre, okay, yeah, that makes a lot of sense. If let some ID equal to self that string to integer get word IDs push ID. Okay, so I don't have to return. Okay, that makes sense. Reference layer. Okay, reference layering and type is match in main. This is 109. As said, okay. Type mismatch when calling simple tokenizer and new vocab because vocab becomes a B3 map, but the tokenizer spec, okay. Oh, what happened? Preprocess is a vector string calling either on just reference to the elements string. Collect therefore creates a hash set strings. Calling iter on hash string just reference to its elements, which are that string. Collecting this yields a bag of okay. Iterating over C to insert into vocab just reference to those elements, meaning the key inserted are of type. Okay, so what is happening here is I was expecting a static type, like kinda I was going over having a B3 map of the expected shape string and I32, and instead what I needed is a string, but since we iterate over and over and over and over, that creates a different kind of yeah, a different structure to say. And I missed the number. I used I32 when it was US size. Yeah. How to fix? Simple the reference layer by deferring copying the reference at each stage and casting USI to I32. Use copy on the ether area to turn into string. Yeah, that makes sense. So instead of preparing everything and having everything here, maybe I can just do this either and I really like it. It's simple to use. Convert the step into back string into be via into ether, which consumes the set and just own a string element directly. This also makes sense, and I love it because it's simple to use, right? Build the vocabulary by casting the use size, okay, which will be where let between new into ether into iter enumerate as I did it. That makes sense. Let me run it. Okay, let me see. Okay, I think it was, yeah, I have still an error. Can you help me to understand? I think it is because I use when I shouldn't. Let's see. Yeah, I mean, I give it a hint to see if that's the error, but I don't know. Yes, you're absolutely right. The error is coming from the placeholder and brace placement in your new code. Here's explanation of the errors. The syntax error, where it's an error also not recognized. Ellipse, a placeholder for code. The compiler tries to parse. Yeah, I mean, this wasn't a stupid error. I should have just leave it like this and understand that it was just a reference to, okay, do whatever you need there. But it's a common error. You will be surprised how many of these things I have in the past. So yeah, I just leave it as an honest mistake. Yeah, I mean it's pretty common because you think AI will handle everything and will give you the correct methodology and the correct syntax without you having to figure out stuff. But it turns out you still have to figure out stuff. But yeah, I'm proud that I did the correct way. Yeah. Lifetime mismatch. This is where L51. Okay. Why this is an error? You declare. Okay, generic. I should put it this. Yeah. Semicolon. Oh, yeah. Return. What? Why this scenario? If you end that in a block or function with an expression that has a semicolon, the expression is evaluated and the block returns the unit type. Since the signature or simple tokenizer encode specifies that it returns a vector I32, adding a semicolon to ID causes type mismatch compile error because it discards the vector. Okay, yeah, that's another level of confusing because yeah, I mean, I was thinking that every time you end up with or you finish a sentence or any line of code, you need to put the semicolon, and it turns out you don't. I mean, there are reasons for doing that, and I was completely unaware of that. And in this case, you cannot do it because you already are specifying what the return would be. And if you don't, if you put it, it will create a different type of return to some extent, or it will discard the vector. I don't know. I mean, this is confusing. Also, it is best practice to add semicolon to the end of ID push. Okay, I miss here. Best practice. My ass. Yeah. Yeah, let's see. It work. This work. Okay, guys. So yeah, it works. I know. I said that I want you to say I, but I was spending a really hard time trying to do it, and I did the block of code myself. So yeah, I will call it a win. I did have to use AI to understand some parts because that was completely new to me. So I need to study this a bit more and try to understand what was going on. But as recap, we just implement our first tokenizer in Rust, which is kind of an accomplishment for everyone here. So yeah, I'm really happy for all of you and all of me and the small help that I have with AI. So yeah, let's just kind of recap on what we did. We built a tokenizer in Rust. How we did it? We started with defining the structure for the simple tokenizer, and we make it public so we can use it into our code. After we did that, we implement the simple tokenizer, which is using a B-tree map or the vocabulary that we already defined, and then we specify what would be the type. In this case would be a string and a number, because remember that we want to pass from the words into a number based on the IDs that we have. And then we define the encode. So we don't have the full part of the encode the code, but at least we were able to implement the encoding part, which is translate words into numbers. So that's a pretty great accomplishment. And yeah, that's how we pass a raw text, we convert to string, we pass it with the same regular expression that we use for our vocabulary. So that's important because you don't want to have mismatch between the regular expression that you use to clean up your data into the vocabulary with the words that you are parsing, because that will create a new unique errors or mismatch between what you are passing and what you want to learn or what you want to understand or tokenize, right? So then you pre-process, you remove everything that is empty space. Then you define two asset vector, and from that vector we extract only the ID. So you pass a text, and that text gets converted into IDs based on the vocabulary that we have. And after that, after we have defined that struct, we use it's pretty simple once you implement it, because it's really similar to Python. We just create simple tokenizer, which is a new tokenizer, and we pass the vocabulary that we already have here, that pass numbers or words and IDs, and from those vocabularies that you load into the tokenizer, you pass a text. Any text will work, and from that text you convert ID. So that's what we did here. You see, 95. So that's what it represents. Let me print so it is easy to see for everyone. Text. This this will be the representation. Yeah. So it's the last he painted, you know? Yeah. So it's 95, the 51, last 88, he 1015, painted 632, you, yeah, but I think it's kind of like that. Maybe this is 51, is 88, the last he painted, okay, 54, which is a comma, you know. Yeah, I think that's the right way to see it. But yeah, guys, we were able to implement this tokenizer, and it works. We, or at least the encoding part. For the next time, we are going to see the encoded, the decoded part, which is you parse the numbers, and this will be get converted into words. So I'm pretty excited about that, and we wrap it up with this Rust session. It was a long session, but it was really fulfilling because we were able to implement the tokenizer from scratch, which was great, guys. So thank you so much for being here, and see you next time. Bye, guys.